Hey guys, in this lesson we would understand how to solve quadratic equations. Let's first understand the meaning of solving equations. Solving equations means finding the value of the independent variable or the variable that is unknown. For example, if we are given 3x plus 1 equal to 5 and the variable that we have to solve for here is just one variable that we see, and that is x. So all we have to do is just isolate x. So we would move everything on the other side. 5 minus 1, we get a 4. X would be equal to 4 over 3. In this example, we are solving for the variable in a linear equation. So for linear equations, we just have to isolate for the unknown variable using opposite operations. Now, how do we solve quadratic equations? We know quadratic equations is three types: standard, vertex, and factored form. So if we will be asked to solve for quadratic equations, we will be asked to solve for the value of x. Now, this is an example of a standard form of quadratic equation. If we are supposed to find out the value of x, we should be given the value of y, because in standard form of quadratic equation, we have x given at two different places. So that's why there's a procedure to solve for x or the independent variable, and that we would learn through the examples that we will be doing in this lesson. If we're given the quadratic equation in the form of vertex, and we're given the y value as any value, let's say 2, and we are asked to solve for x. Now here in this equation, we have x only at one spot, so we can easily isolate for x. All we have to do is just move the numbers on the other side using opposite operation. So this goes on the other side, this gets divided. We get minus 3 divided by 3 is equal to x minus 1 square. This gives us negative 1, x minus 1 square, and then square moves on the other side, becomes the square root of the given number on the other side, as square root of negative number does not exist, so therefore there is no solution for x in this particular example. But these are the general steps that we follow to solve for x when we are given the vertex form of equation. Now if we are given factored form of quadratic equation, then the factored form of quadratic equation is easier to solve if y is 0. Because if y is given to us as 0, then we would have the product of two factors equal to 0. Always remember, when we have product of two things equal to 0, then either one of the two things should be equal to 0. That we can put as note. So when a multiplied by b is 0, then either a is equal to 0 or b is equal to 0. So if in this case we have to solve for x, we would just put each factor, because the whole factor is multiplied by another factor. So the product of these two factors is equal to 0. That's why we put each factor equal to 0, and we would be solving for x. Similarly, we would have x minus 2 equal to 0, so x would be equal to 2. And this is how we get to x values when we have factored form given y is equal to 0 or dependent variable is equal to 0. What if the dependent variable is not equal to 0? Then how do we solve the equations? And how do we solve equations when we are given the standard form? Let's go over that using different examples. The first example is when we are given factored form of quadratic equation and y value is equal to 0. Then how do we solve for x's? Because this is the product of two factors equal to 0, so we put each factor equal to 0 and solve for x. So 2x plus 5 equal to 0 gives us x equal to negative 5 by 2. And x minus 5 equal to 0 gives us x equal to 5. This is how we solve when we are given factored form of quadratic equation equal to 0. Why do we need the factored form in order to solve to be equal to 0? Is because the factored form has x at two different places. Similarly, standard form also has x at two different places. So whenever we see x or the variable that we are solving for at two different places, then the other side of the equal to sign should be equal to 0 in order to solve for the variable. However, that was not the case in vertex form of equation, because in vertex form, we just see x at one spot. So whenever we see the variable that we're solving for at one spot, then the other side could be any number and we just have to isolate for the variable. However, in standard form, we have x at two spots, and in factored form also we have x at two spots. So we need the other side to be equal to 0 in order to solve for x in both of these cases. If the equation is given to us in factored form equal to 0 form, then all we have to do is just put each factor equal to 0 and solve for x. Now what do we do if we're given standard form of equation equal to 0, and how do we solve that? And let's say we're given the question x squared plus 8x plus 12 equal to 0. We notice here that factored form equal to 0 is easy to solve. That's why we would apply the same procedure here, and the procedure here is to turn this to factored form. Once it gets turned to factored form and it is equal to 0, then we solve for x using the same method that we used in example 1. And in order to turn this to factored form, the process is factorization. We have covered up all different techniques of factorization in polynomials unit. If you need to refresh your memory, I would encourage you to watch the playlist Polynomials, where all the different types of factorization techniques are explained. You would find the playlist in our channel, APS Education Math and Science videos. Now coming back to the question, how do we change this to factored form? Because this is a trinomial, we can do factoring trinomial method on this, and a is 1 here. So the first step is to multiply a and c. Product of ac we get is 12. Second step is we are looking for the product 12, and we are looking for sum as 8, that is the middle term. So we are thinking about two numbers in this case. That gives us a product of 12 and sum of 8. And the two numbers that work in this case are 6 and 2, because when 6 and 2 are multiplied, we get a 12. And when 6 and 2 are added, we get an 8. We use these two numbers to write down our final answer, because this is an example where a is 1. So we can use the numbers as is to write on the two factors, and the two factors we get is x plus 6, x plus 2. Now we can rewrite this equation in factored form as x plus 6, x plus 2 equal to 0. Once we get this, then we can put each factor equal to 0 and solve for x. And this is how we get the two answers. So we see here, when we are given the question in the form of standard equation, and the standard equation is equal to 0, and we have to solve for x, or the independent variable, then we change it to factored form. Once we get the two factors, then we put each factor equal to 0 and solve for x. Let's take up another example of standard form of equation just for the sake of practice. Let's say we're given the equation negative 10g squared plus 32g is equal to 6. You know, this is a kind of standard form. However, a standard form of quadratic equation can be solved when the other side is equal to 0. But in this question, we don't see the other side equal to 0. So our first step is to move it on the left side along with the rest of the equation. When we do so, we get negative 10g squared plus 32g minus 6 equal to 0. Now this is exactly matching the standard general form of quadratic equation. And the variable that we are solving for is g. So the first step we have to do is definitely turn this to factored form, because a is negative in this case, and we notice that all of these numbers are going to be factorable with negative 2. So we can factor negative 2 out, so that we are left with 5g squared minus 16g plus 3 equal to 0. These signs get flipped because these numbers are being divided with a negative 2. The next step is we can take this negative 2 on the other side, and we can divide it by 0, because this negative 2 is being multiplied with this whole bracket. This is what we would be able to get. Now, once we get the quadratic equation in a form that is easily factorable, we would try to factor it. So the first step is, because a is 5, we would multiply a and c, and that would give us 15. Second step is we would think of two numbers that would give us a product of 15 and sum of negative 16. And the two numbers are negative 15 and negative 1. Because when we multiply negative 15 and negative 1, we get a positive 15. And when we add negative 15 and negative 1, we get a negative 16. So we can use these numbers to split the middle term. And we can group the first two and the last two terms. We get 5g as a common factor, and we are left with g minus 3 from the first bracket, minus 1, g minus 3 in the second bracket. Finally, we get 5g minus 1. And g minus 3 equal to 0. Now, once we get the equation in factored form, we can solve for g. 5g minus 1 is 0, means g is equal to 1 over 5. G minus 3 is 0, means g is equal to 3. So the two unknown variables, or the two independent variables that we get after solving this, is 1 over 5 and 3. And this is how we solve standard vertex and factored form of equations for unknown variables. We need to make sure that in order to solve the standard and the factored form, the other side should be equal to 0. However, that's not the case with vertex form. One more thing here to remember is that if in case factoring is not possible for a given standard form of equation, and we cannot turn it to factored form, then how do we solve the standard form is to use the quadratic formula that we have learned in the previous lesson. Therefore, in case the standard form of equation is non-factorable, all we have to do is just apply quadratic formula to get the unknown variables.